what is the specific heat of the unknown substance if you have 354 grams of this substance raised by 14 degrees Celsius after absorbing, was this 3,328 joules of heat? Round your answer to 1 decimal, please. Wow, what happened to your answer? We'll see. Okay, so Q equals mc delta T. So we're given delta T 14. So C is equal to Q over C delta T. No, C. M. Hold on. M delta T. So Q is 3,328 joules divided by the mass, which is 354.0 grams. And delta T is 14 degrees Celsius. So C here is just, what's that? 30. 328. Divide 354. Divide 14. I got 6.119 joule per gram degree Celsius. It says 2 1 decimal place, so this is 6.1 joule per gram. You got it correctly, but then you didn't follow instructions. It says 1 decimal place, so it should be 6.1. Yeah, you got it. 6.1. And then the next one, specific heat. It's in joules, then you convert to calorie per gram. So 1 calorie is equal to 4.184 joules, right? So this was 6.1 joules times 1 calorie divide 4.184 joules per gram degree Celsius. So that is 6.1 divide 4.184. So that is 1.458 calorie per gram degree Celsius. It says only 1 decimal place, so this is 1.5 calorie degree Celsius. Is not okay. It should be 1.5 here. See, you almost got the correct answer, or actually you got the correct answer, it's just you didn't follow the instruction. All right. An 11.4 gram sample of graphite with, this is the heat, specific heat, at 59.6 degrees is dropped into a color containing 29 grams of water. C. At what is the final temperature of graphite water mixture round 2? Okay, so this one we equate. Can you now see me writing? So we use energy conservation here. Heat loss, that is just equal to heat gain. So graphite and water. So we just equate them. So the mass of graphite times mc delta T. So Q of graphite is equal to the Q of water. So mass of graphite times the specific heat of graphite times T initial minus T final. Yeah, heat loss. Then mass of water times the specific heat of water times so you won't be confused. I will just use T1. So T1 minus T2. Here, T2 minus T1 because heat is gained. Then we plug in everything. Mass of graphite is 11.4 grams times 0.709 joules per gram degree Celsius. Then temperature, what's the question here? What is the final temperature? Okay, we don't know, but we know the initial temperature. Initial temperature of what's this? What's the initial temperature? 59.6 minus T2 equals, the mass of water is 29.1 grams times specific heat 4.184 joules per gram degree Celsius times T2. Okay, now what's T2 for this? Okay, this one is a bit tricky. So the temperature, the final temperature of graphite is equal to the final temperature of water. Right. So that would be T2 minus 26.5 degrees Celsius. Then we'll see. So T2 here, if you're going to derive, T2 is, okay, can we just multiply everything? It's making this complicated. So 11.4 times 0.709 times 59.6, so that is 481. Let me just, when I change this to black, okay, so that is 481.72296 joules per degree Celsius minus 11.4 times 0.709, that is 8.0826 equals that one, 29.1 times 4.184, this is T2, 121.7544 T2 minus 29.1 times 26.5, that is 3,226.4916. And then we group like terms together. 121.7544 plus 8.0826, that is negative 129.837 T2. Then 481.72296 plus 3226.4916. A lot of numbers here. So this is, oh no, for 3226.491. I got 3,000 here. 3,708.21456. Then divide that by 129.837, that is negative. So T2 is 28.561. It says 1 decimal place, so T2 is 28.6 degrees Celsius. That's my answer. Cover this one. Because that one is a lot of numbers. The previous problem. Okay. Calculate the heat energy when 450 grams of water is condensing at 100 degrees Celsius. Okay, we're given the heat capacity: solid, liquid, gas. Now, heat of vaporization. Round your answer to 3 significant. So it says condensing at 100 degrees Celsius. So that means we use the molar heat of vaporization. No, latent heat. Q delta H vaporization. Yeah, we're only given here that one, 100 degrees Celsius. Because it's already said here that water is condensing. It doesn't start from solid. It's already condensing. So we can calculate directly. Yeah. Condensation means it releases heat. So Q is just 450 grams times, what is the heat of vaporization? 2260. That is negative 2260 joules per gram. So what is that? 450 times 450. This is 1,017,000 joules. Therefore, Q, this negative 1.3 significant figures times 10 to the 6 joules. So this is the answer. Yeah, compared to the previous problems that you needed to solve, because it started from solid, like say ice, and to gas, solid to gas. Of course, it has to, the ice has to melt, right? Then the liquid has to evaporate. You use the heat of vaporization. Okay.